Look at some special angles of some triangles here, and then go ahead and find those values. So if we start out with an equal lateral triangle, then we know that our sides have to all be the same. So if we start out with all our sides being 2, and that means also equilateral also means that it's equal angular, right? So all the angles are the same. This is or you can call it like a regular triangle. Regular just means that the angles are the same and the sides are the same. So it's both equilateral and equal angular. Alright, so then if we go ahead and split this down the middle, okay, that means, or perpendicular bisector, that means it's bisecting this angle. So now this side is 30, this is perpendicular. So then we're really looking at a 30, 60, 90 triangle. And if this is 2, that means this short side is 1. You might remember that from a couple of years ago, dealing with the special cases of 30, 60, 90 triangle. Okay, and then once you have your short side, then you get your long side, right? The opposite of the 60-degree angle is the long side. Opposite of the 30 is the short side, and then our hypotenuse is up across from the right angle. So to find your long side, you take your short side and you multiply it by √3. So that'd be √3. Okay, now if we want to look at where our hypotenuse is 1, that means I would divide this by 2, and if I divide that side by 2, that means I have to divide this by 2 and divide that by 2. So now I'm looking at a 30, 60, 90 with my hypotenuse is 1, my short side or opposite of 30 is 1/2, and the long side opposite of the 60 is √3/2. Okay, so now we can look at, okay, what is the values of 30-degree angle? So we're looking at 30, and we're going to find sine of 30, cosine of 30, tan of 30, and then the reciprocals cosecant, secant, and cotangent of all 30, 30, 30 degrees, 30 degrees. Okay. So sine is opposite. Sine is opposite over hypotenuse, right? So opposite of 30 would be 1/2 over 1. So that would be 1/2. So sine of 30 is equal to half. And cosine of 30 is adjacent, right? Cosine is adjacent over hypotenuse. So adjacent side is the side connected to it, but not the hypotenuse. So that's √3/2 divided by 1. So that is √3/2. Tangent is a little bit trickier, right? Because tangent is opposite over adjacent. So that's opposite. So that's tangent of 30 is equal to opposite over adjacent. Okay, and when I'm taking 1/2 and dividing it by a fraction, √3/2, that means I'm taking 1/2 and timesing it by 2 over √3. So that equals, 2's will cancel here, and I get 1 over √3. Then I have to rationalize it, and I multiply both top and bottom by √3. So I get √3/3. Excuse me. So tangent of 30 is √3/3. Cosecant would be 2, because I'm flipping sine, which is 1/2. Secant would be 2 over √3. So secant is 2 over √3. There I have to rationalize it again. So I get 2√3/3. So 2√3/3 is secant, because it was √3/2, so I had to flip it to 2 over √3, rationalize, I get 2√3/3. And then cotangent would be flipping this tangent. So if I come back to right here and flip this tangent, I'll just get √3. So cotangent of 30 is just √3. And so these come in handy. You can go ahead and also do the 60-degree angle. So looking at that same right triangle, the 30, 60, 90 with 1, 1/2, and √3/2, and go ahead and find the sine, cosine, tangent, and at their reciprocals of 60 degrees. And what you'll notice is, 60 equals 60, is you can do the cofunctions thing, right? The cofunctions would say, okay, well, cosine of 60 is the same as sine of 90 minus 30, right? Or sorry, sine of 30 is the same thing as cosine of 90 minus 30. So sine of 30 was 1/2, and cosine of 90 minus 30 is cosine of 60. So cosine of 60 is also 1/2, right? So I could use those cofunctions in here, and this would be root 3 over 2. Tangent of 60 is the cofunction of cotangent, right? So if I looked at the cotangent answer, I would get cotangent of 30, which is root 3. Then the cofunction would be tangent of 60, would be root 3 as well. And then switch these, right? So this would be root 3 over 3, this would be 2, this would be the 2 root 3 over 3 answer. Okay. So that's, and then you could also do 45, that's our next one. So these do come in handy later on, so when you do 45s, here we have a 45, 45, 90 triangle. So to get to the hypotenuse, you multiply by root 2, one of your sides by root 2. Those are special cases for 45, 45, 90. Now if I want my hypotenuse to be 1, then I would divide this by root 2. So I'd have to divide these by root 2 and this by root 2. And then I'd rationalize, and so I'd get this 45, 45, 90 triangle, as 1 is my hypotenuse and root 2 over 2, root 2 over 2, and then you can find cosine, sine of 45, so that is root 2 over 2, root 2 over just plain 2, sorry, so root 2 over 2, and cosine is also root 2 over 2, and tangent would be sine divided by cosine, so root 2 over 2 divided by root 2 over 2, which equals 1, and then you can flip these. This would just be cosecant of 45 would just be root 2, right, because it's taking this 1/2 and flipping it, and you get just plain root 2, and same thing with secant of 45, it's just root 2, and then cotangent would be 1. Okay, so these make up our kind of our special angles, our trig functions for special angles. And then so if you put it into a grid like this, you could put this on a note card, so then you can kind of figure out what sine, cosine, tangent, and their reciprocals are of 30, 45, and 60. And then this comes in very handy. So if you have this down, right, that's the idea of kind of using, really all I had to do was sine, and then I could use cofunctions to find the other ones, right? So those come in handy. Cofunctions do come in handy. But these will come in handy, 35, 45, 90. You can also do the 90-degree ones as well. 90 degrees basically is just, I think maybe we've done this before, but 90 is up here, so this angle, open it up to 90 degrees. This would be my angle. Here would be my point. You'd do the point 0, 1. My radius is just 1. Same thing over here. If I did 180, 180 would be negative 1 comma 0. 270 would be down here, and this would be 0 comma negative 1. And then both 360 and 0 is 1 for my x, 0 for my y. Alright, so if you memorize those four, you memorize these, really you don't have to memorize the whole thing, right? You can use cofunctions. And really all you have to do, if you know 30, you can use cofunctions to find your 60. And then 45 is pretty easy, because it's just root 2 over 2, or 1. And then the reciprocals are just 1 or root 2. So you don't have to really memorize it all. Okay, so let's go ahead and practice a few problems here. So these problems you can find on page 509. And these are numbers 29, 31, and 33. So 29, 31, and 33. So we'll go ahead and do these ones. And you can use that chart there to do those ones. So on page 509, if you looked at number 29, we'll start there. All right, tangent of 30, you can just look at that chart. Boom, look at that chart. 30 degrees, tangent is sine over cosine. So at 30 degrees, our sine at 30 degrees is our 1/2, and cosine is √3/2. And tangent 30 degrees, that we're in the first quadrant, so it's positive. So then you have to flip this fraction, and you'd get, eventually you simplify it to √3/3. Or sorry, √3, yeah, √3, no. Yes, √3/3, sorry. Because you're going to have to rationalize your 1 over √3. Okay, number 31. So number 31, you're looking at sine of 30. So again, just look at your chart. We already know this from this one. It's 1/2, right? So they probably should have switched those around, right? Should have probably did 31 first. 33. 33 is secant of 30. So secant of 30 degrees. So that is 1 over cosine of 30 degrees. And cosine of 30 degrees, like we did from 29, is √3/2. So I just have to flip that, right? So it becomes 2 over √3. We rationalize it. So we get 2 √3/3. So that means secant of 30 degrees is 2 √3/3. So those are all your answers. So you'll use that table a lot, and again, you don't have to memorize the whole thing. You can memorize pretty much like half of it, and you would find the other half by using cofunctions and the reciprocals, right? All right, so that's it for this video.